Good morning, everyone. My name is Benjamie Cani, and I am here for a teaching demonstration. The subject matter will be mathematics. Ariel, please lead us in prayer. Jesus, can you pray? Amen. Good morning, students. Good morning, class. How are you today? Okay, fantastic. All right, so as I call out your names, please say present. So, and please be attentive as well. Anibalo, Juliet, Zaragoza, clear? Very good. So, there's only one absent in this class, and actually, the parent has sent me a direct message via Facebook, and she was saying that her daughter is sick. So, please do pray for her. So that by tomorrow or the next few days, she will be able to join our class. Alright. And please be reminded also that we have the classroom rules, and I just want to reiterate to you guys. Of course, everyone was early today, so be consistent with being attentive to your teachers while they are teaching, and also I can see some papers under your chair, so please pick up all the pieces of papers before leaving our class this morning. Okay, well done. And also, I just want to make sure that respect is being adhered to among your classmates, and make sure that you respect each other's personal belongings. And as we start the class, make sure that you raise your hands so that you will be recognized. Okay, everything is clear? Alright, very good. So let's move now to our recap or the review for our past lesson, which was last week. Alright, so basically last week we have discussed some basic geometric figures, and I want you to please raise your hands as I flash something on the screen, some figures on the screen, and make sure that everyone is attentive. Alright. So Ariel, please tell me, what do you call by this figure? Very good. It's called point. So on the screen we can see points A, point B, and point C. Very good. Sit down. Okay, Maria? Okay. What do you call this figure over here? Yes, very good. It's called line. Okay, very good. Please sit down. Joseph, what about this figure? Very good. It's called a line segment. Okay, good job. Please sit down. And what about Rosario? What do you call this figure over here? Very good. It's called a ring. Alright. Good job. And the last one, Josephine. Okay, what's this? Okay, very good. It's called an angle. Alright. And we have also discussed last week class about the differences between types of lines. Alright, so as I'll be flashing, okay, before you move on, okay, it's a summary of what we have just reviewed regarding the basic geometric figures. So here is the point A, and then there's this line segment, okay, line segment AB, and then there's also this line AB, okay. For the ray, it's ray AB, and for the angle, it's angle A, or we can also name it as angle CAB, okay, with being A in the center. Alright, so again, we have discussed some basic or differences between types of lines. Okay, so we can name this figure over here. Maria, again. Okay, very good. It's called a parallel lines. Okay, they are called parallel lines. Later we will be going through again just a quick review of their definitions. All right. What about this one, Dominic? Okay, very good. It's called perpendicular lines. Okay? So these lines are called perpendicular lines. And what about this one? Josefa. Okay, what do you call this one? This one. Okay, very good. It's called a intersecting lines. Alright. So when we say parallel lines, once again, these are two lines that remain the same distance apart at all times and never intersect. Okay? So as you can see from the figure over here, these are two lines. So even if you extend these lines, if you make an imaginary lines, they won't cross or they won't intersect each other. So that's why it's called parallel lines. So given the symbol, it's line AB is parallel. So this is the symbol for parallelism, okay? It's parallel to line CD. So moving on now to the perpendicular line. We say perpendicular lines, these are two lines that intersect and form right angles. Okay, so from this figure, from this example, we can see that lines PQ is perpendicular to line MN. Okay? Because they are forming 90 degrees measurement, which are also called right angles. Okay? So we can form right angle over here, over here, over here, and over here. Is that clear, guys? Okay, very good. Alright, for the last lines, which are called intersecting lines, they are lines that meet or cross each other. Alright? So from the given example, we have line SD intersect with line UV. Okay? So from the word itself, intersect, it's very understandable. So they will cross, right, each other. They will meet each other. Alright. So, can somebody tell me the basic or the classification of angles also? Okay, so can someone tell me, as I flash a figure on the screen, can someone tell me the type of angle being formed in this illustration? Okay, Dominic, what do you call this angle? Okay, very good. It's called an acute angle. How about this one, Joseph? Okay, very good. It's called a right angle. So from the illustration itself, right angle, as I mentioned earlier, the measurement is 90 degrees. Alright, very good. Please sit down. Okay, how about Kian? What do you call this figure or this angle over here? Okay, very good. It's called an obtuse angle. Alright, so later we will be tackling the measurements and what's the limit of the measurements. Okay, how about this one? Alright, Dahlia, okay? Please tell me what angle is this? Okay, very good. It's called a straight angle. Okay? Please sit down. Pedro. Okay. Can you tell me what angle is this? What angle is being formed here? Yes, the curved one. Yes. Alright, very good. It's called an obtuse angle. Very good. Sit down, please. What about Peter? Yes. What is this? What do you call this angle? Okay, very good. It's called a full or complete angle. Alright. And by the way, how do we know that how to really derive or get the correct measurement? What do you use? What instrument do you use? Anyone? Yes? Maria? Okay, very good. It's called protractor. Alright? So basically, protractor is being used as is an instrument that is being used to measure the angle. All right, and I believe last week we have already discussed, and even you also used, or you also started using the protractor. Am I right? Very good. Okay. So here's the summary. So we say acute angle is the measurement is less than 90 degrees. Okay? When we say right angle, the measurement should be exactly 90 degrees. And for obtuse angle, the measurement should be greater than 90 degrees and less than 180 degrees. Alright? And for the straight line, over here, the measurement is exactly 180 degrees. And for the reflex angle, the measurement should be greater than 180 degrees. Okay? Very good. So, for the full angle, or they also call it complete angle, the measurement is exactly 360 degrees. Okay, so basically, I think everyone is ready for the next topic. So, which is called polygons. Alright. And so, what shapes do you know that have many sides? By the way, for our topic today, we will be discussing under the subject matter. Under this topic, polygons, we will be discussing the convexity of polygons. We'll also discuss the angles, and we'll also discuss the sides. Okay, so again, going back, what shapes do you know that have many sides? Yes? Peter? Yes? You're raising your hand? Can you give an example? Yes, very good. It's triangle, okay? So, how many sides that a triangle has? Okay, yes. From the words of tri means three sides. Who else? Darius? Very good. Square. Square is also considered as a polygon with many sides. It's a shape that has many sides. And how many sides does square have? Very good. It has 4 sides. Very good. Alright. Who else? Okay. Yes, Joseph? Yeah, okay, very good. Again, class, before you answer, you must raise your hand first, okay? Don't give me the answer right away, okay? But you're right, it's called pentagon, alright? Pentagon is an example also of a shape that has many sides. Alright, very good. How many sides again? From the word itself, penta. Do you still remember your elementary topics or classes in mathematics? Yes, very good. It has, when you say penta, it means 5. It has 5 sides. Okay, however, what makes this shape similar or different? Are they similar? Are they different? What do you think? Okay, very good. Alright. So it has similarities, yes. Roldan was correct. It has similarities, and it also has differences. Okay, but let's tackle first the similarities. What makes polygons similar? Alright, a polygon is always a closed figure. Okay, so take note, I have highlighted the word closed figure with straight sides. Okay, what else? And it is made of straight lines. Okay, so when based on the given shapes earlier, the lines were straight. Okay, there were no curved lines. Right? Okay, very good. So third one is they have vertices and angles. So every polygon has corners. So corners is also called vertices. All right. And interior angles. So they have vertices and angles. Okay? And the fourth one is they lie on a flat surface. So we're talking here about the two-dimensional figures. Okay, or shapes. So polygons are two-dimensional in shapes. Alright, so let's now move on to the number of sides. Okay, I mean the differences of polygons. Number one is the number of sides. Alright, so from the given example earlier, there were three shapes, right? One was triangle, one was square, and one was pentagon. So the triangle has three sides, square has four sides, and pentagon has five sides. So this is very self-explanatory, alright? So number two, the differences. What makes polygons different is that of its side lengths and angles. Okay, so the lengths and the angles that it forms. So the regular polygons, when you say regular polygons, all sides and angles are equal. Do you understand? Okay, very good. All sides and angles are equal, but the regular polygons, the sides and angles are not equal. Okay? So regular and irregular. You say regular, all sides and angles are equal. Irregular, sides and angles are not equal. Okay? Please take note of that. Okay. And for its convexity, alright, for its convexity and whether the polygon is concave, so that's also one of the that's also what makes it different. Okay, on the convex, whether it's convex or concave. So we see convex, all angles point outward. Alright, so all angles point outward, and there are no indentations. Is that clear? Alright, very good. So when we say concave, it has at least one angle that caves inward. Okay? So for convex, the angles point outward. And then for concave, the angle caves inward. Alright? So outward for convex and inward for concave. Alright, very good. So let's now move on to, okay, before I flash it. So have you ever seen shapes used in bahay kubo or in a local crafts? Yes, Teresa? Yes, so what do you notice? Have you seen a bahay kubo before or even now? It's very famous, right? Okay, yeah. Why is it famous? What do you think? Why do you think it's famous? Yes, very good. Bahay kubo is a traditional Filipino home. It symbolizes our resourcefulness. And even when I was also young, we used to have bahay kubo at first. Before my parents, during their initial stage of their marriage. So we had a bahay kubo back then. However, when we moved to the city, then we had a new house. So it's a modern house, so to speak. Alright, so the walls, based on the picture or based on the what is being flashed on the screen, we can see some shape like rectangles, rectangles or squares, and these are quadrilaterals, right? Alright, very good. Which is a type of, very good, it's a polygon. And the roof, when you look at the roof, forms a triangle or a trapezoid. Do you agree? Yeah, very good, yes, you're right. The floor patterns, if made of bamboo or wood, sometimes repeat in the geometric designs using parallelograms or hexagons. The bahay, what about the next, this one? Have you been to the city of Vigan in Ilocos? Anybody? Oh yeah. So what have you noticed when you were there? Yes, very good. So the bahay na bato or the stone houses in Vigan are made with rectangular, correct? And square shapes for doors, windows, and floor plans. And the roofs may also form triangles and trapezoids, especially in the traditional architectural style. But here's one more. It's called a polygon house. Have you ever seen this? Have you been to Manila? Because this is found in Taguig, Manila, okay, in Metro Manila. This is found in Taguig, and as you can see, based on the figures, it's very clear that it's really intended, it's really built using architectural designs, and the shapes are polygons. Okay? But here's the question. Can all shapes with many sides be called polygons? What do you think? Romeo? What do you think? Can all shapes with many sides be called polygons? Yes or no? Why no? Why no? You are right. Okay. Not all shapes with many sides can be called polygons. Yeah. Romeo is good. What about Juliet? Juliet, what do you think is the reason? You are right. So there are properties that we have to satisfy. Okay. So to be a polygon, a shape must meet these rules. Number one is it must be a closed shape. Okay, take note, it's a closed shape, guys. Okay, and the shape's sides must connect end to end. So to form a complete loop. Okay, it's not open but it's closed. If it's open or has gaps, it's not a polygon. Alright. So it must be made only of straight lines. Yes, Jessica was right. So it must be made only of straight lines and no curves or rounded edges allowed. Alright? If a shape has curved sides, it's not a polygon. Okay, do you understand? Everybody clear? Okay, good job. So it must be, yes, Sebastian was right. It must be two-dimensional flat. So it should be 2D, just like what I have discussed earlier on. So if it's 3D, it's a solid. It's not a polygon. Okay, well, everyone is really doing a great job today. So examples of shapes that are not polygons. Okay, a circle. Why? Because it doesn't have straight sides. Like the circle doesn't have a straight sides. A shape with both straight and curved edges, an open figure like an incomplete triangle. So here's the thing. Even if a shape has many sides, it can only be called a polygon if it's closed. Next one is if it has straight sides. And the third one, if it lies in a flat plane. Okay? Good job, everyone. Okay, for your group activity, you have to cut out some different forms of different types of polygons. Right? I'll be giving you 5 minutes to do that. All right. So I will be expecting that you'll be creative in cutting out some different polygons. All right. Okay, time is up. So earlier, when we were cutting out the polygons, different types of polygons, I was taking pictures, and yeah, they were very nice. They were very fantastic. Although some need to be, need to be practicing. Right? So here are your outputs. Okay, very good. So we have the types of triangles. And based on the sides, based on the angles, so I believe you're all familiar with this already. Okay. And some also cut out different types of quadrilaterals. Alright. Good job, everyone. So can someone tell me, yes, Maria, what shape is this? How many sides? 5. So it's called? Very good. How about this one, Romeo? Yes. How many sides? 6, right? Yeah. So it's called Hexagon. Very good. Good job. What about this one? How many sides does it have? 7. So when 7 sides, what do you call this? Heptagon. Very good. Wow, fantastic guys. What about this one? How many sides does this have? Yes, 3, 4, 8. So what do you call this? It's called octagon. Good job. Sit down. Okay, what about Albert? What do you call this? How many sides does this have? 9 sides. So what do you call this? It's called nonagon. Very good. Oh, fantastic. How about this one? Yes, Jessica? Yes. Okay, it has 10 sides. Alright, so what do you call this polygon? In this shape. Yes, it's called decagon. Very good. Alright, good job everyone. Alright, so moving on. Can you tell me whether these shapes are called or can be classified as convex or concave? What do you think? Yes, Alfaro? Yeah. Okay. Convex. Very good. Very good. Good job. So, why convex? Because it satisfies, some basic properties. All right. So, what are the properties of convex polygon? A convex polygon is a polygon where all vertices point inwards. So, in a while, I'll be showing you some examples of a convex polygon. Alright? So remember, all vertices point inwards. Okay? The next property is a convex polygon where all the interior angles are less than 180 degrees. And the third one is a convex polygon is a polygon where the line joining every 2 points of it lies completely inside it. So here are the examples. Okay, so if you look at it, each figure over here, all vertices point inwards. When we talk about vertices, this is vertex, 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 vertex. So all the vertices point inwards. Okay? None of the shape over here has a vertex pointing outwards. So it's always inwards. So all the vertices point inwards. And the interior angles are less than 180 degrees. So later we will discuss that one. But just take note that interior angles should be less than 180 degrees. And it lies completely inside it. So there are two lines joining, or 2 points joining together. So, for example, if you put a line over here and a line over here, it will always lie inside the polygon inside. Okay. So this is the one I was talking about, the convex polygon of n sides. The formula for the sum of the interior angles is as follows. Sum of the interior angles is equal to 180 times the number of sides minus 2 degrees. Okay, in a convex polygon of n sides, the formula for the sum of exterior angles is as follows. Sum of exterior angles is equal to 360 degrees. Very good. Here's an example. So I just want to make sure that this is very clear to all of you class. So all interior angles measure less than 180 degrees. Okay? So the measurement of this angle is less than 180 degrees, less than 180 degrees, and less than 180 degrees, less than 180 degrees. And all, as you can see on the screen, all diagonals, the imaginary lines that we have just formed over here lie inside a closed figure. So none of the diagonals is lying outside. Okay? So I hope that is very clear to you. Alright? And so here is an example again. How do we get it? So what shape, by the way, do we have here? This is, what polygon is this? This is called a, how many sides? it has 1, 2, 3, 4, 5 sides. So you see 5 sides, what shape is this? It's called a pentagon. Very good. So here is how we are going to get the measurements of the angles and also state whether it is a convex polygon. Okay, in order to check whether it's a convex polygon. So from the given example, as we know, the given pentagon, this is pentagon A, B, C, D, and E. All interior angles are of equal measure. Alright? And we will state later on whether it's a convex polygon. Okay, so let's move now to the solution. As we know, interior angle of a regular polygon, the formula is equal to n minus 2 times 180 degrees divided by the number of sides. So here, the given for n is 5. So that means we just need to substitute. This is the number of sides, minus 2 times 180 divided by 5. So 5 minus 2 is 3 times 180 degrees divided by 5 is equal to 108 degrees. Therefore, each angle over here measures 108 degrees. That means it satisfies the first property, which states that all interior angles measure less than 180 degrees. Therefore, we can conclude that this pentagon over here, since the measure is less than 180 degrees, is considered a convex polygon. Alright. How about this one? What do you think? Is this convex or concave? Yes, Adolfo. Concave. Very good. Yes, you're right. This is concave. How about this one? Jerome? Convex or concave? Look at the diagram properly. Look at the shape properly. Okay, very good. It's concave. Fantastic. And so, concave polygon, a non-convex, we also call it concave, or a non-convex polygon is a polygon that has at least one interior angle greater than 180 degrees. Okay? So, for the convex, the angle must be less than 180 degrees. But for concave, it should be greater than 180 degrees. Fantastic. And it is a shape where at least some portion of it points inward. In this case, in this illustration, can you see? Alright. So, in this illustration, this point over here is pointing inward. Okay? This portion over here pointing inwards. And for this one, it is also pointing inwards. And both are pointing inwards. So that's how we classify whether a polygon is a concave or a convex polygon. So in this case, this is a concave polygon. Alright, another example. Pizza. Okay? So at first it was whole pizza. Alright, so one slice has been taken out. And so we can see a line forming here. So these points inward. Therefore, this shape is a concave shape. Alright, here are the examples also. Okay, we have a cross. Just take note, some points are pointing inwards. Okay, this is pointing inwards, pointing inwards, pointing inwards, and this one is pointing inwards. Okay, is that clear, guys? Class? Very good. Okay, so let's now move on to the classification again, just to make sure that everyone is familiar. Alright? So we say convex shapes from here, for example, the full outline of the convex shape points outwards. Okay? There are no dents. Alright? From here, there's a dent. And that's the reason why it's pointing inwards. So this is convex, this is concave. And over here, all interior angles of a convex polygon are less than 180 degrees. So using a protractor, okay, this will measure less than 180 degrees. Or for this one, at least one interior angle is greater than 180 degrees. So if you notice, class, this one is, by merely looking at it, we can conclude that the measurement is greater than 180 degrees. Because if we extend a line over here, let's say an imaginary line over here, it's called a straight line, right? And a straight line has what's the measurement of a straight line? 180 degrees. So if we extend a line over here, then we can conclude that this angle measures more than or greater than 180 degrees. Okay, quickly, let's move. Move on to the convex shapes. For this particular property, the line joining any 2 points of the convex shape lies completely inside it. So wherever you create or connect 2 lines inside in this polygon, it will always lie inside. Okay? No matter how small or how big is the distance, okay, it will always lie inside. And for this one, the line joining any 2 points, so like, say for example, this point and this point, if you join them together, you see there's an overlap or there's a line lying outside the polygon. Okay? Very good. So, okay, so again, let's move on now to our summary or generalization, okay? So again, just to make sure everybody is clear about our topic today. So, Rosario, can you please, in your own words, can you please define what polygon, what a convex polygon is? Okay, very good. So all interior angles are less than 180 degrees and there are no indentations. Okay, there's no curve. Alright? So, Maria, what is a concave polygon? Okay, so a concave polygon is a polygon that has at least one very good interior angle greater than 180 degrees and it must have at least 4 sides. Okay, so Uli, what is it? What is an angle? Okay, the sum of the interior angles using the formula n minus 2 times 180 degrees where n is the number of sides. Okay, so that is how we will be getting the measurement of the sum of the interior angles. Okay, and what about the sides? Okay, it's very simple. You just count the number of sides of a polygon. Count off the line segments forming the polygon. Alright, so very good everyone. So now let's move on to, okay, very good. So what is a polygon again, Joshua? It's a closed figure made up of straight line segments. And so again, the number of sides, we can classify a polygon by its number of sides. And by counting the number of sides, we would know, like the triangle, it has 3 sides, square has 4 sides, and for the pentagon, it has 5 sides, so on and so forth. Hexagon, heptagon, octagon, nonagon, and decagon. Alright. So, a convex polygon we have just discussed, and I believe everyone is clear, and I hope everyone is clear about our subject matter today, that a convex polygon has all the interior angles less than 100, very good, just 180 degrees, and no indentation, you are right. While a concave polygon has at least one interior angle, what's the measurement? It should be Mario, greater than 180 degrees and appears to have a caved-in part. Okay, just like the previous example that I have just flashed on the screen. And the sum of the interior angles of a polygon can be found what is the formula if you have to find the sum of the interior angles of a polygon? Yes, Rahul? Yes, Rahul? Yes, it's n minus 2 times 180 degrees, where n is the number of sides. Very good. You're really good today, guys. Okay, so what have you learned in today's, or maybe just one of you can state in your own words, what have you learned in our discussion, and how do we relate, whether you can relate, or yeah, just your perception in today's discussion. Okay, maybe Rachel. Yes, Rachel. Okay? Alright? Listen very carefully, guys. Okay? Alright? Very good. So, she had learned that polygons are not just shapes. They have rules. Yes, fantastic. They have rules. If all the corners point outward, it's convex. If one points inward, it's concave. Great job, guys. You can also figure out the total angles inside by using a simple formula, which is n minus 2 times 180 degrees. Very good, fantastic. Okay, get one more sheet of paper. Okay, which of these figures are considered polygons? Letter A, B, C, D, E, or F. If you think there are multiple answers, then you state the letters. Okay? Let's say A, comma, D, comma, F, comma. You do, that is how you do it. Alright, next. Find the interior angles of a regular convex heptagon in a diagram. Okay, name the following polygons. Okay, very good. Okay, what is the answer? Answer is letter A, letters A, B, and C. Okay, I believe you have already exchanged papers, right? Okay, because this is our practice ever since. Alright, so define the interior angles of a regular convex heptagon in the diagram. Okay, the solution is n minus 2 times 180. So by the way, this is a heptagon. You can say 7 sides. So 7 minus 2 times 180 degrees, 5 times 180 degrees is equal to 980 degrees, which is the sum of all interior angles over here. The sum. Okay? And so each interior angle, just divide by 7, and we will get 128.67 degrees. Okay, the following polygons, this is called nonagon, decagon, dodecagon. Okay, how many got perfect score? Wow, great job, guys. Everybody got the perfect score. Well done. Okay, so for your assignment, find polygons in local architecture, crafts, or nature. Design a simple local structure or craft utilizing polygons, explaining their properties, and also explore advanced concepts like regular polygons and symmetry in Filipino patterns. I believe we have 1 week to do it because we are on a semestral break. So, and also we're nearing the next holiday. So I hope that you can comply and bring your assignments next meeting. That will be a week later. Alright? So does anybody have a question? Do you have any questions, guys? Everything is clear? Any questions? Okay. Goodbye for now, guys. Goodbye, students. Alright. See you.